Evening, sir.
Good evening. Hello.
Sir, actually, sir, we have some doubts, sir.
Yeah.
Throughout the class, okay, about we are learning about the how the solar cell behaves, their characteristics, first generation, second generation, third generation. That's all.
Mm. Yes.
But see, suppose we have to we want to build one. Actually, I am from construction field. Yes, sir.
Yeah.
So we are planning to build a suppose one 4 megawatt.
Uh,
Hello, 4 megawatt.
your hello.
So
Your voice is not proper, dear.
okay. So now it's okay, sir.
Uh, Tell me.
No.
Yeah.
Sir, actually, just tell me, sir. Suppose some calculations, design calculations. Suppose we are planning to build a 1 megawatt solar power plant.
Yeah.
Yes,
Yeah.
sir.
Yeah. Yeah.
So, how many modules should be installed, and what is the modules availability at market? This at least 5 minutes or 10 minutes you can explain. Actually, beneficial for me, sir. Actually, because I am from construction side.
Yeah.
The
So
working principles, everything I have clear.
every
Yes.
ev- every module has a rating. You can
Yes,
see.
sir.
So if you join in series, then you will be find what is the output. So
So
please.
actually, in
Yeah.
single module, how many voltage is there? In a array, how many? I don't know, sir. If you explain, at least for 5 minutes, it will be beneficial for us.
So
For a
dear.
single solar
Okay.
in a
One,
module, you
one
can also
minute.
have it.
1 minute. Let me find a site for you.
Yes.
Solar. Hello. Okay, 1 minute. Uh, let's see. We can. uh, see this. Yes. Okay. So, uh, in C in PV model, we know that the maximum power put in IV solar cell P max, I max, V max. Okay,
P.
so
P.
yeah, P max I into V.
P
Hello.
is divided by PE, power in.
If J is there, this is
Yes.
this is the I.
I.
Okay, so you know the maximum power point. Yes, this is the maximum power point like that here. This is the I curve, I max, V max. Uh, this type of like IV curve from a solar cell. We can calculate P max from a solar cell. Okay, and then we have a power array of n number of solar cell like that, PV array in summation, so you can calculate total power of the PV array in summation of the maximum power. What? Summation of the maximum power individual module connected in series. What? We have to sum of the power individually module. Okay. Uh, if there is a module, there is a rating in module P max power up to output power. Okay. So you have to sum like that P1, P2, P3. If M is the Slico panel, the maximum power of a single module and a number of the module can be connected in series, then the total power of the PV array is how? Pm into N. Such type of like how many times this number. So it is the simple calculation. You can sum up power. If individual module has given you power, rating power. Okay, so let we discuss. If you doubt, please more clarification. You can mail me. I will send you the exact calculation how good.
Yes, sir, if you send me, it will be beneficial for us.
Okay,
Actually,
okay.
sir, each one solar cell,
Yeah,
because
yeah.
each, normally silicon solar cell gives how many powers? Only one cell.
One power solar
Market.
cell around 25% efficiency.
It is yes, yes,
Okay, around single crystal.
yes,
Okay,
yes.
so what is the efficiency from what comparison? What is this number tells you? What is the efficiency? Output
I input.
with respect to input. Yes. So what is the input for this? In first class we have already discussed 1.5 am globally rate. There is a global SI unit for solar cell. Yes or no? 1.5 am. Yes. What is the power of this number?
So, to check.
1000, 1000 like that. Yes or no?
Yes, sir. Yes,
That
sir.
is
1,000.
watt per something. Watt per
What per
centimeter,
meter?
centimeter square.
Yes, yes.
Like that. So this is with respect to the input. This is give only 25%. Okay,
Yes.
but this is the sufficient power generation. No, single junction solar, single junction or single band gap material cannot exceed 33% output power. Why? This is the Shockley-Queisser limit or theoretically maximum power. Why not exceed? What happened? Do you think? Where is the loss? Hello? Why not
This is
100%? Why not 100%?
because the number of photon received not
Yes.
converted to electron hole pair, total
And
photon.
the
That's why.
related to the band gap,
Yes.
if the light is incident like that, energy
Not
like that, let's see, incident photon actually
yes.
has energy, but output will be only much.
Yes.
Yes. So
Not
there is a thermal loss, so many losses.
yes.
So why not exceed? So this is the explain answer. And theoretically calculate shock equation and single junction material cannot exceed 33, which is band gap around 1.14, like that. I'm not exactly remember, but like that. And 1.14 or 1.13 around. So can we move further? Let's discuss today
Yes, sir.
question. Okay. So first question is, are you able to see? First
Yes,
question.
sir.
Okay. Which of the following type of silicon exhibit the lowest carrier movability?
Amorphous.
Mm, Carrier movability. This is the movability.
Amorphous.
Movability.
Amorphously.
Please think like that. Movability depend what parameter? Temperature, alpha power, let's say, and material quality. Yes or no? Applied electric field. You know the formula. Yes. And how can you calculate movability? Which experiment gives you movability? So this is the related to the question quality, material quality. Now, can you reply? Are you able to now? Hello, please write the answer. You can write in chat box. Gaurav, Malay.
Sir, exactly what you want, sir. Carrier mobility, how you can uh, derive carrier mobility or what experiment need
No,
for
no.
carrier mobility?
I want to physically interpretation how carrier mobility uh, characterize our solar cell. So it's basically related to the material quality. In solar cell, we have first check what is the movability of the electron or holes. If the electron or hole movability is good, then material is good. So, but single crystal or polycrystal and amorphous, which type of material is good quality? Single crystal or polycrystal or amorphous? Single crystal is good,
So,
yes or no?
single crystal good. Single crystal good column.
Quality is good. because
Polycrystalline also good quality.
no ground boundaries in polycrystal
No grain boundaries.
has so many ground boundaries.
Mhm.
Poly
Yes.
amorphous is too much defects.
Yes.
So lowest carrier mobility would be
Amorphous.
amorphous. Okay, so if the defect density or material quality is good, then carrier mobility will be good. So if we single crystal, then only then amorphous. Yes, this will be order. So let's see the explanation. What is the explanation? Amorphous silicon, and here is the explanation. In solid state physics, the electron mobility characterize how quickly an electron can move through a metal or semiconductor when pulled by an electric field. This is the definition. There is an analogous quantity for holes, also called hole mobility, electron mobility. The terms carrier mobility differ in general in both electron and hole. Electron and hole mobility are a special case of electric mobility of charged particle in fluids under a applied electric field. So when an electric field is applied across the piece of material, the electron responds by moving with an average velocity called drift velocity. Then electric mobility mu is defined at Vd equal to Ed or mu equal to Vd by E. Yes, this is the formula, but semiconductor movability depend on the impurity concentration first. Please see, including donor acceptor concentration, defects concentration, what is the temperature, and electron hole concentration. So it is also depend on the electric field, particularly at high field when the velocity saturate occur. So it can be determined from the Hall effects. Experiment is Hall effect or infrared from transistor behavior. Do you know Hall effect? Hello. If you want to more, uh, you can search. Let me search Wikipedia. There is the explanation, all things uh, given. So derivation is also here and relation. Yes, it is related to the time period. Movability also diffusion energy. So Hall effect. You can calculate movability from Hall Hall experiment. So there is a whole experiment setup measurement. Sir, already discussed in class. Yes or no? So you can follow. There is the explanation. Okay. So let's see one by one. Uh, let derivation. Starting from Newton's second law, we know the F equal to ma, or we can calculate like that acceleration. A is the acceleration of collision. If two electron collides uh, in F is the electric force from the electric field, and m is the effective mass of electron. So force equal to QE, where E is the electronic charge. So acceleration can be written like that: A equal to minus E electronic charge multiply with electric field and multiply divide by effective mass. So this is the acceleration of electron between collision. The drift velocity is therefore Vt equal to acceleration with and time multiply by time. Tau is the mean free time between two collision. So Vt equal to a tau c. You have to let's put the value of a. What is the value of a? A equal to minus E electronic charge multiplied by electric field divided by Ma, and so this is the Vd equal to E tau c divided by Ma multiplied by E. So what will be the value of movability? Please compare. Vt equal to E tau c by divided by mass relative to the hole or electron. Okay. Yes, there is the more explanation related to the summation relation of, and this is the diffusion about. So if you know, if you want to more, please search Wikipedia. Okay. Uh, so let's move further. This is enough. You can
Yes.
you can drive like that. Like, we know the A equal to A equal to ma, or what is the F for electric field? If you apply electric field between two plates, electronic charge, electron scatter, or like that, a collision between two is the time. So what will be the value? A minus E divided by effective mass. If it equal to A into tau c, to carrier charge carrier lifetime. Put the value of A E into tau c. So please compare now this formula and this formula, which equal to mu E and which equal to tau c. So this will be the movability. So what is the value? Charge tau c divided by m. It is related to the lifetime also. Charge carrier lifetime. Okay.
Yes.
Okay, let's move further. Second question. The starting material in manufacturing of the semiconductor grade silicon is. Now, are you able to see my slides?
Yes, sir.
Yeah.
Yes,
Please answer. Please,
sir.
please answer. The starting material in the manufacturing of semiconductor grade silicon is. Sir,
Sir, trichlorosilane. D.
yeah, yeah. So this is the cement process. In cement process, the starting material is trichlorosilane. Okay, there is the explanation how silicon is made by a cement process. Sir, already discussed in class. I have taken picture for sir lecture.
Yes.
Hello, 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 Mile.
Yes, sir.
Okay,
Sure. This is
let
already discussed Siemens process. Right?
sir not discuss.
Yes, sir. Definitely. Total process, Siemens process. Only Siemens process is declared, discussed, sir. Out of three processes.
Your voice
Siemens
is
process is.
not clear to me.
Actually, I told you, sir, already discussed, sir.
Yeah, yeah.
Siemens process.
Okay, okay. So let's move further. So which of the following belong to the second generation solar cell technology? First, what is the first generation solar technology for regarding the solar cell?
Sir, A and C.
A and C.
Yes.
No, B and E.
Sir, first generation. A and C.
Okay, first generation A and C.
He told me, but the first generation.
And left is
Sir, so B and E. Gallium arsenide is also first generation.
acha.
D, E.
Okay. So second is thin film. Second generation is regarding
Thin film.
thin
So that's
film principle. Okay. So amorphous silicon and cadmium telluride is the second generation. Okay. This is the first. Then okay, let's move further. The process used for manufacturing semiconductor grade silicon is R. Manufacturing semiconductor grade silicon is R. Please answer.
sir, A and D. Union carbide process and Siemens process.
Okay. So A, D answer. Okay. So sir already discussed in class. This is the cement process used for 60% used worldwide, 15% union carbide and 15% methyl carbonate carbonation process. Semiconductor silicon grade. Preparation of volatile Si4 purification then decomposition to element silicon by produce and this is
Sir,
yeah,
sir, in assignment number 7, sir, question number 3. Okay.
yeah.
I think there is some wrong. So actually the answer.
What is
Assignment number 7, question number 3.
1 minute, let me
Yes.
find assignment 7.
Question number 3, sir.
Wait.
But in this as lecture, I have choose Siemens process, Union Carbide process, and Ethyl Corporation process. Okay, but in answer sheet only Siemens process and Union Carbide process. My one number detected.
Third question, which of the following process is
Question number
used?
3.
Yeah. Question number 3 in assignment 7. Yes, sir.
Assignment 7.
Which of the following processes are used for the manufacturing semiconductor grade silicon? And option is
The
Union
Siemens
Carbide.
process, Union Carbide and Ethyl Corporation. But in answer is only shown Siemens process and Union Carbide. My one number is deduct.
Oh, let me note. Then I will inform the instructor. Okay. This question may be deleted or something like that. So let me highlight this. Please wait 1 minute. Okay, this also will be the answer. I will tell you to the instruction. Okay. Yeah, you are right. Ethyl corporation process is also. Thank you for your information. Okay, let's move further. Which of the following belong to the family of chalcogenide?
A and D, cadmium sulfide and cadmium telluride.
And D. So there is the explanation. A chalcogenide is chemical compound consists of at least one chalcogenide anion and at least one more electropositive element. Although all group 16 elements of the periodic table are defined as the chalcogenide. Okay. In term of chalcogenide is more commonly re- reverse 4 sulfide, selenide, telluride, or polonide rather than the oxide. So you can see there is a sulfide, there is telluride. So silicon is not there, silicon not, and arsenide also not. So sulfide and telluride will be the answer. Okay. So mm, let's move further. Which of the following is are commonly impurity element in metallurgical grade silicon? Please answer. Commonly. Please answer the question. You have 5 minutes.
Ammonium and calcium.
Okay. Mm, and there is the sir already discussed in class with percentage. You can see in slides.
What is the material Ti? Ti means selenium, sir.
Yeah, yeah. You can follow periodic table. You heard what is the symbol of.
Class 12.
Okay. This is the aluminum percentage impurity and FeL, aluminum, calcium. So commonly is aluminum and calcium. Around 6% is calcium and aluminum is around maximum 0.7. Okay, so let's move further. The intermixture of cadmium selenide and cadmium telluride layered in cadmium telluride solar cell leads to. Please answer the question. You have 5 minutes. I will come back in 5 minutes. Okay. Hello, what will be the answer? Okay, decrease in quantum efficiency. Decrease in quantum efficiency at lower wavelength. So let's see explanation. Are you there, Malay? Hello. So let's see explanation. You can see in graph there is the external quantum efficiency y-axis with respect to the wavelength. So first blue response is reduced due to the first surface recombination. So this is related to the surface loss, surface side recombination loss. How? If surface is not good, then so many loss will be there. Then to reduce the overall quantum efficiency cause reflection and how diffusion length. This is related to the material bulk, and red response is reduced due to the rare surface recombination. This is related to this side, then this side, and this side. So this is the ideal curve, and this is the experimental black one with respect to the red ideal quantum efficiency. No light is absorbed below the band gap, so the quantum efficiency is zero along wavelength. So wavelength, how shorter wavelength is absorbed by the surface is lambda is short, longer will be the through the material. Okay, so incident photon absorbed by the material then produce electron hole pairs, and electron hole pairs go to the respectively electrode. If the number is unity with respect to the photon, then quantum efficiency will be 100%. But there is always loss, so quantum efficiency will be less from the unity. So there is a loss you can see in the picture. So quantum efficiency if high, then our solar cell is good. So solar cell has like that characteristic VOC, JSC, quantum efficiency, and fill factor. This is the four characteristics of solar cell. Okay, Malay, are you there? Hello. So, intermixing cadmium telluride and layer solar cell leads to decrease in quantum efficiency at lower side. Why? Uh, this intermixing reduce the surface losses, improve the surface quality. So that's why decrement in quantum efficiency at lower wavelength. This is the lower side wavelength. This is the higher lower wavelength. This is the high as compared to the this side to this side. Or energy inversely proportional to, we know the, or you can say like that. Please remember, you know the energy relation with respect to the wavelength. Say by lambda exactly this number related to the nanometer, or this is in electron volt. Okay, let's move further. The p-type character of the gallium arsenide can be enhanced by. Please answer the question. There is the four option: substituting arsenide with zinc, substituting arsenide with silicon, substituting gallium with tin, substituting gallium with selenium, substituting arsenide with copper. P character. Please answer the question. Nale, are you there? P-type character means whole. So means whole is no responsible for conduction. So answer is substituting arsenic with zinc. And sir already discussed in class. You can see the explanation. N-type doping, Ga side at this side will be responsible for N-types. Ac silicon SN10, while P-type doping for zinc, manganese, carbon, A side. So arsenic with zinc, you can see zinc, Zn. So answer is substituting arsenic with zinc, and you can see in graph also. Let's discuss. There is increment in band gap with respect to the absorption coefficient. If the impurity is mixing, then you can see absorption coefficient also affect. Let's move further. Which of the following can be used as a window layer in gallium arsenide solar cell? Window layer for
E and D, InGas and LGas.
B and D. So this is the third and fourth group solar cell, and window layer you can see base of the gallium arsenide can be tuned by the doping gallium, indium gallium arsenide, aluminum gallium arsenide. So indium gallium arsenide and aluminum. Clear? So what is the feature of this gallium arsenide? You can see this is the band gap and doping, higher carrier movability than the silicon, higher temperature used to better than silicon, radiation 5 to 10 times is expensive, but this is expensive solar cell. This is used for space related application. Okay, let me move further. Cadmium chloride treatment in the cadmium chloride solar cell result in answer.
D, reduce defect density.
And if the
Versus
defect
A,
density,
larger grain size.
if the density is reduced, means grain size will be improved also. So this is the answer.
Yes.
So cadmium telluride uh, as a standard calibre heat treatment must be carried out in order to improve the cell performance. Has been proved a key process in step application. High efficient reported to able to enhance the grain growth, reduce the defect density in the film, promote the interdiffusion, junction interface, passivation grain boundary, improve the solar cell efficiency. Okay, so this is all about today. Let's go.
Sir, today is your last lecture, no, sir?
No, no, one more is at lecture
One
classes.
more.
Yeah, this
Well,
is the
sir,
yes.
Monday, next Monday, I think next Sunday, the final exam.
This is one more should be how could possible this, because this is the 8 lecture classes. This is seventh assignment. One more assignment should be. So let me discuss more things about solar cell. Can we discuss 15 to like
Yes, sir.
okay,
Yes,
okay.
sir. Yes.
I have
Assist.
a book regarding solar cell, good book. Let me show you. Yeah, this is the book, The Physics of the Solar Cell by Jenny Nelson. Okay, so in this book, first is about the photovoltaic effect, brief history, photovoltaic solar cell power generation, characteristic of photovoltaic, then principle of PV, basic. You can find all things related to the solar cell, whole electron semiconductor junction, analysis of PN junction, microcrystalline solar cell, second generation also, thin film, managing light traps. Okay, or limit strategy, how limit. So let's see.
Sir,
Yeah,
sir, there is no uh, dye sensitized solar cell.
yeah.
Is there you have any books, sir? Dye sensitized solar cell.
Okay. Uh,
Yes, because in SAS lecture, in dye sensitized liquid dye, we have used some problem. That's why we have converted liquid dye to solid dye. Okay, and the solid dye next step is the perovskite.
yeah, yeah.
Yes, I think I want to study like this perovskite solar cells.
Perovskite. Okay, perovskite is uh, literature review. So many literature review. If you want to, let me share you literature review. The books is not there.
Anything, sir. Like, anything, sir. Share.
Yeah, yeah.
Really.
Organic
Yes.
perovskite. I have a book regarding the perovskite.
Focus, focus,
Let me share you. This is the book
focus, sir, please.
Organic Inorganic Halide Perovskite. Okay, let me share you. Exercises. Yeah, please type your email ID in chat box. Malay. Please share me your email ID. Okay,
Already given, sir. Like,
okay. Gmail at the rate intech yes .com.
please. Sir,
Yeah,
ECC. Sir,
yeah. This is
ECC.
ECC.
Sir, yes, sir.
Oh,
You write CC.
okay, okay. This is wrong. In .com.
CC.
Okay, this is right.
Yes, sir. Yes, sir. Okay, sir.
Okay, this is the perovskite solar cell book.
So, like, I never. That was it. Very common.
Yeah, done. Did you receive? So this is the structure and hello, Malay. If you want to, I have a good literature for you. And uh, 1 minute, 1 minute. And,
Same.
yes. Mm, yes, Malay. Are you able to see this literature? Halide perovskite photovoltaic background with status and future perspective. This is the good review. Uh, this is too much.
Last one exam.
Do you have access of chemical review? Yes.
What is this chemical level? Okay.
This is the article. This is
Yes.
general chemical review. This is the impact factor of 72. This is the highly reputed general. So this is the too much big side. I am not able to send you because this the file is that you are trying to set exceed the attachment limit.
Then
So you can find like you can search like that halide perovskite
yes,
photovoltaic
eight.
background status and future prospect. I will share you. Okay, 1 minute.
Yes.
You can search directly in internet. Send it. Just yeah. So let me show you how.
Question cancel.
Yes, this is the history of solar. Let's see number of papers in 2009 to 2018. This is the growth rate of the in perovskite field research. You can see in bar chart. Yes. So this is the uh, hot hot field perovskite today. Okay, and there is the all about the perovskite. What is the band gap? How formation of band gap? What is the material APX site? And what what could be the structure, device structure and type and IPPIN. This is the energy band gap arrangement. How solar cell is working perovskite and too much improvement. Yeah, A site, X site also mixing. What could be the A site element 4 mixing B site and X site. So this is the nice review. This is like a book
Yes,
for perovskite solar cell regarding today. What is the strength?
it's very good. Yes, because currently
Yeah.
we are looking for the perovskite cells.
Okay. Okay. I am also working on perovskite.
Yes, sir. You told me you
Yeah.
last slide you showed
Yeah.
on your presentation on perovskite.
Yeah. Yeah. Yeah.
That's
So basic is this, and basic is always should be remember. And this is the dark IV characteristic in solar it in this book. I already said you. This is the band gap. What is the VOC JSC could be for maximum area about. And please remember this
that's
two concept.
and this book also, if you want, please share, sir. Because
Already
this is
said
also
you.
basic.
Already said you.
Okay, sir. Okay. Good.
You can see there is a effect of series and resistance. Shunt resistance should be high and series resistance should be low. And this is the circuit equivalent. You can see regarding solar cell. And already this is the related to the so input M 1.5 air mass coefficient angle, also how absorption can happen, all things. Yeah, there is the, let's see. This is the calculation related to the single junction band gap solar cell at 1.5 Kosley Shocker limit. You can see single junction cannot exceed maximum efficiency.
80%.
Yeah,
80%.
this is 1.5, this is 1, so it is around 1.13 or 1.4 maybe. Okay, so so many losses. You can improve efficiency by tandem solar cell like that. Yeah, this is the explanation regarding losses. And also how can you improve utilize of the solar more spectrum, so you can build multi-junction solar cell. This is the cloud field. Okay, carrier generation. Radiative, non-radiative, OJ. Shall we already discuss these things? Radiative, non-radiative, OJ.
Yes, yes, yes.
Okay,
Audio
okay.
recombination.
You can follow this book. Whole things there. This is actually nice book. And junction, yeah. How junction is working. There is a Fermi level, stabilized field. Analyze of P junction, PN junction. This is the built-in potential. People are joining, but we have already discussed. Okay, so let me show one more time. Then we complete today's lecture. So please let me discuss one more time because people are joining. So first question is we have discussed like that about the career movability. Career movability depend what is what is the quality of the material. This is the explanation. So this is really dependent on impurity, defects, temperature, electron. This is can be calculated by the Hall effects. And second, we have discussed about the semiconductor grade silicon. So this material is trichlorosilane in Siemens process. And third question is regarding the second generation solar cell. This is second generation thin film solar cell. So we know the answer and a process for manufacturing semiconductor grade. Uh, this is the process, Siemens process, union carbide, erythyl carbonation process. Which of the following chalcogenide is sulfide, selenide, or telluride? And which of the following are commonly impurity element in the metal? And aluminum and calcium. Which of the following is are commonly impurity in the metallurgical grade silicon? Okay, you can see in percentage. So already discussed in class. And then treatment of intermixtion of cadmium sulfide and cadmium telluride improve the surface quality, so decreasing quantum efficiency at lower wavelength sites. P-type characteristic of gallium arsenide can be enhanced by this is the material for P-type characteristic and window layer 4. So this is the 2 and last question is get treatment cadmium chloride treatment. So improve the surface quality, reduce the defect density, grain. Thank you. Okay, thank you guys.
Sir, mail still not received, sir.
Yeah.
Not received. Yeah.
Hello.
Sir, mail is not received. Yes.
Mail not received.
Good.
One minute. One minute.
Yes, good.
Let me check.
சும்மா இந்த மாதிரி பிஹேவ் பண்றாங்க இது செக்ஷுவல் ஹராஸ்மெண்டா இல்லையா இப்போ சொல்றாங்க இது மாதிரி பிஹேவ் பண்றா செக்ஷுவல் ஹராஸ்மெண்ட் இதே இதை திரும்ப போட்டு இது ஹராஸ்மெண்டா இல்லையான்னு கேட்பான் எஸ் நோ எஸ் சார் எஸ் சார்
This is your email ID, right? Please see.
dmola@tcc.com. Sir, you write L or I? L.
1 minute. This is my payroll.
Link it.
1 minute. Copy your email ID. Then you have some money. Okay, copy. Wait 1 minute. Now check.
Sir, I will check. Little bit hang. System is hang.
Uh, 1 minute. Now please check. I have sent to right.
My system is hang.
The system is in.
My system. My
Okay.
PC.
Please see. Yeah, already.
Malay. Sir, I is L.
Yeah,
Right? I in entry. This is L, sir.
yeah. I. This is
L
right
or
now.
I, sir?
This is right now.
Yes. Sir, this is L or I? Yes, sir.
I.
Already
I.
received. Sir, just now received.
Okay, okay. Thank
Received, sir. Received.
you. Okay, okay. Thank
Thank
you.
you, sir.
Thank you. When
Next
will?
class,
Yeah.
your last class today or next Monday?
When exam? When will be
This
exam?
Sunday.
This Sunday.
Yes, 26.
So one more lecture is remaining. How could possible? 26. I don't know.
Sir, what about this assignment 7, question number 3, sir?
Uh, I will inform the instructor.
Okay, sir, please,
Okay.
because one number deducted.
Okay. Okay. Thank you. Thank you, Malay.
Please, sir. Thank you.